Hi, what's up everyone? This is Kareem from the Mathemagic channel. Today we're going to look at this wonderful question 3D, which was a Math Olympiad question from the elementary and middle school Olympiads in 2011. Shout out for the kids at the Harbour School of Hong Kong for doing this question with me today. And I'm going to show you a neat trick to do this question a lot faster than by just counting all the sides. So let's get into it. Okay, so the enunciate of the question is question 3D, supposed to take you 6 minutes, so if you can save a bit of time, that'll be great. The figure shown is built from 4 1x1 squares, so we imagine those are the little squares here. These are like 1x1, and then 4 2x2 squares, so these are 2x2, 3 3x3 squares, so these are 3s, and then you have a 4x4 square at the bottom here. And so I imagine, looking for the perimeter of this figure here, that the first thing that someone would do is simply to say 1 plus 2 plus there's another 1 on the ledge here because it's 2 less than the 3, and then counting all of that. And we'll get there, and it'll probably take a minute or two, and it won't be too bad. But I just want to point your attention to something that's pretty helpful here. Let's imagine we have a square, and in this square the perimeter of the shape is going to be 10, 10, 10, 10, and you can just say that the perimeter is going to be 10 times 4, which is 40. Now I want to point your attention to this other shape here, which is not a square, but we've pushed the sides in a little bit, and so it's not exactly to scale, but let's imagine that this is 9 and this is 9, and these little edges are going to be 1 each. So it would be the same as a 10 by 10 square, but it's just kind of pushed in a little bit. So it's the same as a 10 by 10 square. Now, the area, of course, is quite different, and we're not asking you to calculate the area here, but the area would be a little bit smaller than the area of the square on the left, right? The area of the square on the left is 100. This is a bit smaller. However, when you look at the perimeter, you'll have 10 and 10, and then here you'll have 9 plus 1 plus 1 plus 9, which ends up being the same. It's still 10 and 10, even though we've made a little enclosure like this and we've pushed it in. And so whenever you have these questions which are shapes which could be like a bigger shape, but it's been pushed in a little bit, it's got the same perimeter. So we've affected the area, but not the perimeter. And this is very important in the question we have here. And so if we were to think about this line here going straight up and going straight across and going straight down and then going straight across again, it'll be a lot like a square that's been pushed in a bunch of places. So all you need to do in this case is just to simply think of this as a square or a rectangle that's been caved in a little bit. And so if we do 4 plus 3, which is 7, 7 plus 2, which is 9, 9 plus 1, which is 10, you end up with a side length both on the side and on this side, on the bottom bit. So on the bottom bit here, you'll have a length of 10. And this vertical sort of dimension here will also have a length of 10. And so in the end, it's very much like this square on the left that I drew. It'll be a 10 by 10 by 10 by 10 kind of shape, which is not really a square. Okay, so the perimeter of this shape in this case, the perimeter is equal to 40, and this takes not a second at all. All you had to do here was to realize that it was a shape that is 4 plus 3 plus 2 plus 1, and then at the bottom also 4 plus 3 plus 2 plus 1. And so in terms of the perimeter, it'll behave exactly the same way as the square which we have on the left. I hope you enjoyed this neat trick to this little Math Olympiad question from 2011. Next time you see a shape and you're asked to find the perimeter, make sure that you can see whether perhaps you can find a bigger shape that encloses the whole shape and will have an equal perimeter. That could save you a lot of time, and it's a smart little trick. It's nice to find smart steps when we do questions. Until next time, see you on the Mathemagic channel. Thank you so much, and goodbye.